Hey there, my fellow intellectuals. Welcome back to Highly Variable. This is episode 3. I am your host, Kyle Cabasares, and today is a very special episode because it is the third episode in my podcast, and 3 happens to be my favorite number. I think it probably stems from video games, to be honest, if I think about it really hard. If anyone's played video games like Mario games or Zelda games, 3 always seems to be the magic number that video game players like myself just seem to know and love, because it's like 3 hits and the boss is dead, or you're given 3 lives to start the game, or 3 hearts in Zelda. So 3 just seems to be everywhere. I ended up wearing 3 a lot in sports, especially in basketball. That was my number throughout high school for me when I played basketball, so 3 was my number. I think also because in baseball, if you're the third batter, that pretty much means you're the best overall hitter on your team, if I'm not mistaken. It's usually 3 or 4. 4 is usually the cleanup hitter, who is like usually the best power hitter, and then 3 is usually the best overall hitter in my diagnosis, I guess, of the batting order in baseball. So, being able to, whoa, I don't know if you heard that, but my water bottle to my left just made this popping sound that kind of freaked me out, but I'm okay. I'm okay. That's the main important thing, that I'm okay. Because if I'm not okay, we can't have this episode. So, yeah, stupid water bottle just scaring me like that. So, where was I? Yeah, 3. 3 is great. 3 is life. 3 is me. 23 and me. Except I'm not 23 anymore. I'm 24. So 24 in me, but that doesn't rhyme. So, no 24 in me. Anyways, I don't know why I just started talking about that. That's weird. That's just weird. I'm weird. I'm weird. I just say weird things, and you listen because you think this is entertaining for some reason. And if you do think it's entertaining, thank you for tuning in again and listening to me for the 3rd time. So today I wanted to talk about a number of things. The first thing on my list here is this week in graduate school. It is currently Friday. So Friday, reportedly my self-diagnosed second best day of the week, or my second assessed. I don't know. You know what I'm trying to say. It's my personal second favorite day of the week. What is my first favorite day of the week? Well, obviously it's Saturday. It's tomorrow. Because the way I explained to my friends when I was a kid, right? Because no one had this amazing insight when they were 5, 6, 7 years old, right? That you see, on Saturday, you don't have to get up early, nor do you have to sleep early. Because on Friday, you have to get up early because it's still a work or a school day, but then you don't have to sleep early because there's no school or work the next day for most people. But then Saturday, you have neither of those, right? Sunday, it's the opposite of Friday. You have to not wake up early, but you have to go to bed early because the week starts the next day. So obviously Saturday has to be the best day of the week based on Kyle's metric, right? Does anyone disagree with me? If you disagree, tell me what your favorite day of the week is. I'm very curious to know. I'm going to bet that like 99% of people are not going to pick Monday. And now that I say that, I think people are just going to comment, yeah, Monday's my favorite day of the week, for sure. I want to be on my grind. I love working. I'm such a workaholic. Monday, best day of the week. Absolutely. Hands down. But I think that means you'd just be trolling me at that point. But if Monday really is your favorite day of the week, I am surprised, but more power to you. You can get through a week better than I can. So, awesome. So what did I do this week exactly? Well, this week was a bit of a roller coaster, as is most weeks in graduate school. I was tasked with doing a few things for my advisor in terms of dynamical modeling for these black hole masses. I don't really want to get into the details that much because, again, I keep mentioning this in every episode, but just scooping. I just don't want to, sell my secrets out there. But I was trying to do a few things. I got a little bit stuck on one of them, and I was recommended to look at this paper that had information regarding stuff that I needed to use in my modeling process. Contacted the author of the paper, and turns out maybe the result in the paper isn't the best avenue to explore in the research. So now that kind of left me in this state of, okay, what am I going to do now? And so I left myself to think about what to do. But fortunately, I had a few other things that I was tasked with doing, such as mentoring an undergraduate summer student. So did some mentoring this week. It was pretty fun. I really like teaching. I really do like to teach. So that was pretty fun. But it also means I have a little bit less time per week to focus on my own research. And as for that, there are a few roadblocks in the way that I've been trying to chip away at for the longest time. And I think I'm close to making some sort of a breakthrough. I keep saying breakthrough like it's a common thing. It's not a common thing whatsoever, but maybe not breakthrough is the right word. Maybe just making some progress, I suppose. I think I have a way of adapting my code to do something that it needs to do. I essentially got explained how to do it by my advisor, and there is a paper that has a similar procedure described on it, but it's really hard, actually, for me at least, to translate what someone does in a paper to actually doing it yourself. If anyone has to recreate something that someone else did in a paper from X amount of years ago, you might find it's actually a little bit harder than you might first imagine, because when you get down to it, the specifics of how to do a certain thing might not actually be in the paper. They might be very general about it, but being very specific may not be the case for that paper. So that was very vague, I know, but it's hard to talk about something that's really detailed in a very vague way, but you can't disclose of it completely. So I apologize for that if it was very vague, but know that I'm working in Python. I am looking at images from both ALMA, which stands for the Atacama Large Millimeter Array. It's a radio array down in Chile. And I'm also looking at images from the Hubble Space Telescope. So the HST has been taking images of the galaxies I've been looking at, and I've been looking at HST images as well in different bands. In terms of, by bands, I mean filter bands, wavelength bands, frequency bands. So electromagnetic spectrum bands that the images were taken in. So yeah, that was my week in graduate school, mentoring, working on HST/ALMA stuff, getting stuck, but reading a bit and trying to find my way through. So overall, average week, just an average week in the summer. Though I can't believe July is almost half over. It kind of gets me worried because it means I should probably get on it a little bit more, because I really want to get a paper out by hopefully September or so, and at this rate it doesn't look that great, so I'm going to have to keep working really hard towards that. So yeah, let's hope that I can do that. Otherwise this podcast might be shorter than I would like, and you would like, if you're listening. So right, I have my second thing here. This is unrelated, but I recently just came back from a trip to San Jose, California. I was up in the Bay Area, but I was up in the mountains of Mount Hamilton. Mount Hamilton is towards the east of San Jose, and on top of Mount Hamilton rests Lick Observatory, which was the first observatory built at a very high location. So it was built back in the 1880s, I believe. I think 1888, if I'm not mistaken. And it houses a lot of telescopes there. You have like the Nickel 1 meter, you have the Shane 3 meter, which is the biggest telescope on the mountain. You also have the 36-inch Great Refractor in the public observatory building. So it is a fully functioning, respected observatory. And I went up there last month in June to observe some quasars during the night. And I had to go up there. I had to fly in the morning, and I had to get a lift. Not an actual lift app lift, but I had to get a lift from my PhD advisor. He was there in the Bay Area for other reasons, and he came to pick me up from the airport. And then we went to Lick Observatory together and observed together that night these quasars. But the observing wasn't, or I should say the observational campaign isn't under our control. We are in a supporting role, I should say, for this group that has had funding to get telescope time at Lick Observatory for AGN. So by AGN I mean active galactic nuclei, so galaxies that are very bright and luminous, or have a very bright and luminous compact central region. And this group got funding. They're from Korea. They got funding from Samsung, of all places, to look at these active galaxies, which I don't know about you, but that just sounds very strange to me. Active galaxies being funded by Samsung, of all people. But if they got the money and they want to spend it on active galaxies, more power to them. So awesome. So this group in Korea, they have money from Samsung, or they had money from Samsung at least. They may have spent it all on getting this telescope time. And they've outsourced to a bunch of people like my advisor and other groups from like UCLA, and I think Cal Poly has people on the team as well that have volunteered to do some of the observing for them. So I was observing for this Korean group these quasars, and excuse me, these quasars, if you don't know, a quasar is a very bright, compact point source-like object on the sky that is powered by a supermassive black hole in the central region that has this swirling accretion disk as matter is being stripped from stars and gas in the regions nearby the black hole and just accreting towards it. So you just see this accretion of matter, which is known as the accretion disk, where you get this really high amount of power and energy being released that we can observe with our telescopes on Earth. So these quasars are very interesting. They're also very good probes of the early universe, when the universe was very young. And we were observing them, or I was observing them. Actually, I was the main person in the driver's seat. The whole point of me going up there was to be the main astronomer on the night, if you will. I was the guy. I was the person in the chair controlling partially the observation. So there's also a support astronomer who actually controls the telescope and tilts it and slews it around. So I don't do that, but I do pick the targets. I do start the exposures, as in I'm collecting the data, essentially. So we were using the Shane 3 meter, which was the biggest telescope on the mountaintop, but we were using the CAST spectrograph, which is a spectrograph that records the spectrum of light that comes onto its detector. So we were looking at the spectra of these AGN, of these quasars, and I'm not going to be doing the data analysis. That's going to be on the Korean groups, but it was fun. It was really fun. I had a really good time. I thought it was going to be very stressful because, one, I have sat on a few observing runs as just a volunteer, as a watcher, someone who's not controlling anything, just observing the observers, literally observing the observers, and just seeing all the amount of work that goes into them and how much detail is required to be kept to have a successful run was kind of intimidating, but I took good notes while I was a volunteer, and I went up to the mountaintop, and I think I was pretty well prepared, and I think my advisor was pretty happy with how the night turned out. We actually got clouded out, unfortunately, because clouds came in at around 3 in the morning, and so we had to shut down the telescope. But overall, I think it was a very good observing run. It was my very good first experience as being the main driver of the telescope. And I'm looking forward to do it again. I'm going to be doing it again next month, I believe, and I'm scheduled to do it for the next couple of months, for a couple of weeks between each run, maybe several weeks between each run. So that was that. So yeah, I'm an observer. I'm an observational astrophysicist / astronomer. Come at me, man. So yeah, sorry. My mind just blanked right there. I didn't really know how to continue, how to sort of just segue onto that, or out of that. So apologies on that. But as we move on, I'm going to talk about the Bibles of my field. So if you're on YouTube, I'm sorry if you're listening on Spotify or Apple or Google Play. I have the 2 Bibles of my field right next to me. I have this one book. It's called Galactic Astronomy by James Binney and Michael Merrifield. And then the other book, which is like the other Bible. Who knew there were 2 Bibles, right? The other Bible is Galactic Dynamics. So I guess you could think of this as New Testament. You could think of Galactic Astronomy as Old Testament. I don't know. I don't know how you want to break it up. But what are these books about? Well, essentially, Galactic Astronomy is the Observer's Bible. So for people who do observational work like me, this is a book on observations of galaxies and a little bit on the theory of those observations, on galactic structure, and on the photometry of these galaxies, as in how do we look at the light coming in them, how do we gather that light, how is it analyzed, and what are the ways that we interpret the data that is collected from these astronomical observations. So if you're looking at the YouTube version of this podcast, you'll see that the book right next to me has this picture of the Milky Way in the near infrared. It's imaged in the near infrared by the COBE satellite. So that is what that cover picture is, and that's what the book is about. It's a very popular book that is a little bit on the older side. It is from 1998, I believe, or 1999, so it came out when I was either 3 or 4 years old, so relatively older, but still a very useful reference. Some things haven't changed in astronomy, and it's still a really good book, and I really recommend you picking it up if you can. It's not that common, actually. I've had a hard time finding copies of this book, so if you're interested in galactic astronomy and you want a really good reference that I'd say is a classic, Galactic Astronomy is your book. Next up is Galactic Dynamics by James Binney and Scott Tremaine. Now, if you notice, James Binney is a co-author on both of these books, so he's pretty well renowned. He teaches at Oxford, I believe, Oxford or Cambridge. I can't remember which exactly. But interestingly enough, I didn't know this, but I looked this up. James Binney, as an astrophysicist, his PhD advisor also advised Stephen Hawking. So he and Stephen Hawking are academic siblings. So rest in peace to Stephen Hawking. Those who don't know, Stephen Hawking was this amazing astrophysicist who was in a wheelchair because he had ALS, but lived way, way longer beyond his life expectancy. So he passed away recently, and his contributions to physics is just amazing. And as I say this, I feel kind of like, who doesn't know who Stephen Hawking is? Come on, Kyle. Everyone should know who Stephen Hawking is. But maybe you don't, and if you don't, he's amazing. So, and you should look him up, and you should really read his book, A Brief History of Time, which I believe I have on my... Oh, I do have it on my shelf. I'm looking right at it. Here it is. If you see this, look at that. A Brief History of Time by Stephen Hawking. I just pulled that out of thin air. So, highly recommend that book. That was like the book in high school that got me into physics. So, if you got the time, pick that up, give it a read. It's really great. But I was really meant to be talking about Galactic Dynamics. So, Galactic Dynamics is on the sort of the dynamical side of galaxies in terms of using physics to understand how galaxies merge, how galaxies form, how do we understand how stars move in the mid-planes of galaxies, and how do we make predictions on these orbits based on the shape of the galaxy. So those are the kinds of questions that Galactic Dynamics tries to answer, and it is a beast. It is a very, very challenging textbook. It scares me. I didn't know how else to put it, but it scares me, man. That book is intense. And I'm just going to set the record here. I did a minor in math as an undergrad, so I'm no slouch. I don't want to think I'm a slouch when it comes to doing math. And I think most people who know me would say, yeah, you're pretty good at math. Okay, so I think I'm pretty good at math. That book scares me mathematically. And maybe it shouldn't, but there are these steps where they just make these transformations that I would have never imagined in millions of years, and they sort of skip steps and derivations and they want you to fill them in, and I'm like, I don't want to do this. Like, this makes me feel pain. So maybe it's good that I'm not a dynamicist and I'm an observer, so yeah, I guess that just shows I'm in the right place. But maybe one day, I will be able to tackle this book, but it's not a huge priority right now. I just take pieces of it here and there to help me with my research. So that's my Bible, my Bibles, sorry, my two Bibles, or my Old Testament, my New Testament, whatever. And now I want to talk a little bit about graduate school in another regard. I'm going to talk about my choosing of my PhD advisor. I want to make a whole video on this and go into more detail as to how to make this decision for people who are in this position. But my story is long, and I don't want to keep you any longer than you need to be kept. But the story goes something like this. My PhD advisor was actually the first professor from UCI that I met with during my visitation weekend. So when you get accepted to graduate school, the school will often invite you to come visit the campus, talk to some of the faculty, talk to some of the current graduate students, just to get a feel for how you like the place. And oddly enough, even though I wasn't doing astrophysics at the time, I was doing what is known as condensed matter, which is focusing on materials like quantum materials, stuff on really small scales, and where people often work in labs and have to synthesize materials. So I had nothing to do with astronomy or astrophysics at the time. But I had a meeting with my current advisor, who is an astronomer here at UCI. And I had a really good meeting with him. He was really nice. He was very helpful in just terms of talking about UCI and what UCI had to offer, and his research sounded very interesting, even though I had really no idea what he was talking about at the time. And I remember leaving that meeting thinking to myself, wow, I'm kind of sad I don't do astronomy, because that guy was pretty cool. And then as I progressed in graduate school during my first year, I just slowly became more disenchanted with condensed matter physics, and I realized that condensed matter physics was the only thing really available to me as an undergraduate at UC Merced, which is why I stuck with it and why I thought I'd go to graduate school in it. But it really wasn't the thing that drove me just completely insane, curious, out of curiosity, right? Drove me insane for other reasons. But nonetheless, I really wasn't feeling condensed matter anymore, and I thought that I needed a change, and so I decided to go into astronomy, and I went to my advisor, I went to my advisor, who wasn't my advisor at the time, but just said, hey, I'm thinking about switching to astronomy. Do you have a spot in your group? And sure enough, he did. He had one spot because one student was getting ready to leave because they were graduating with their PhD, and I essentially inherited the project that this person, who is now a postdoc, had. So I'm pretty much taking over where this person left off, and I'm in a good place with my advisor. And if you want to know the process of how I got to picking him, it was a lot. I essentially organized interviews with professors in the physics department at UCI, and I met with them in their office for maybe 30 minutes to 45 minutes, and I just asked them a series of questions. And those of you who are like scratching their head as like, why do you do this? Like, that sounds kind of weird. The reason is, if you don't know, if you're not just familiar with academic environments, your advisor is one of the most important decisions when it comes to graduate school. Like, picking a good advisor is just super important to your success as a graduate student, because there are so many horror stories I've heard of people picking terrible advisors and it negatively affecting them for the rest of their career, essentially. So hearing those things, I knew that I had to pick somebody who had my best interest at heart, who I thought was a proactive researcher, someone who wasn't going to just rest on their laurels because they had met tenure now, and someone who could teach me the ropes and was willing to tell me what I needed to do when I needed to do it, but was also not a micromanager, and someone who could just let me go and, do the work that they told me to do, and I could come back to them with questions if I had any. So I interviewed a lot of different professors. A lot of the time I could rule them out within 5 minutes of just talking to them. I could just tell, yeah, just based on this conversation, I'm not feeling it. Like, I'm not feeling this vibe I'm with this professor. And maybe, with you it takes longer or shorter, but I just knew off the bat with some people it wasn't going to work out. So with my advisor, I had a great feeling when I had a meeting with him, and the fact he was willing to take me in with no experience in astronomy whatsoever, that meant a lot to me. So yeah, I'm in a really good place with this group, and I think I am in good position to advance to candidacy, which is the next thing I'm going to talk about now. So for those who don't know, advancing to candidacy is a point in graduate school where if you're going for your PhD, you have to officially become a PhD candidate, and you have to advance in order to do that. And by advancing, it requires you to form a committee of professors in your department and essentially presenting a body of work that you've done, and your future plans towards your PhD and what you hope to accomplish. So you have to present all the stuff that you're doing and all the stuff you think you're going to be doing for the rest of your PhD to this group of professors, and you pretty much have to convince them that you know what you're doing and you know what you're talking about. And if that sounds terrifying to you, that sounds terrifying to me. It is kind of scary and intimidating. I mean, I like talking, as you can tell, but talking about a really, really specific field, of course it's my area of research, but just imagine talking to people who are just, older than you, who have done this for much longer than you have, before you even knew this stuff existed, and you have to try and convince them that you know what you're talking about. It sounds a little bit intimidating, and I should probably try and advance by the spring of next year. So I have a little bit less than a year. My plan was to read one of these Bibles, specifically Galactic Astronomy, cover to cover, and just really know galactic astronomy really well, plus some of radio astronomy, because that's essentially the research that I'm doing. I'm doing radio astronomy. So that was my plan. I've been reading galactic astronomy, and it's been going good, but it still sometimes feels like it's not enough. Also need to read some papers as well. There's this one really long review paper that I've been meaning to read that's just so... Oh, it's like a book. It's like almost 80 pages, and that's just painful. But it's really important to read, and I've been meaning to do it, but it's going to cost a lot of paper and ink. So I got to get around doing that sometime. So advancing to candidacy, right, next on the agenda, I got to form a committee. And the committee, thankfully, I have the choice in choosing the professors, and I have an idea of who I want, and I think that they're cool with me. I think they like me. That's usually a good sign when you're picking your committee. If they, like you as a person, that usually works well in your favor. You usually don't want to have people who kind of have a negative opinion of you. So I have some people in mind, and I'm hoping that it will go well, and you'll definitely hear more of this as we get closer to advancement. So yeah, that is graduate school life in a nutshell. That was the majority of this podcast, I know. If you were burnt out on academics and you were like, bring back the sports, then I'm sorry, you might have to wait until next time. I think that is all I really wanted to talk about today. So thank you again for listening to the third episode of Highly Variable. I'm your host, Kyle Kapasadis, and I will see you guys later.